Hello, everybody. Welcome to today's event. Just going to wait a minute or so, and then we'll dive into things. All right, just in the interest of time, I'm going to just get started. And whoever's here, great, welcome. And whoever streaming in will stream in, and just catch me in the middle of this, and most will catch up on the recording. So thanks everybody for joining today's event. It's private match funding and Department of War, formerly known as the DoD, pitch event.
Hey, I just want to let you know, it's still the DoD. The Department of War is a second name. It's not formally known. It's still the DoD.
Okay. Thank you very much for that. Okay, so rather Department of War, also known as the DoD, pitch event. Just a little bit of background. So the event is jointly run by Eagle Point Funding, which is a grant consultancy, and Deep Tech Showcase, which is a business development firm, which are sister companies. And just to better understand kind of the context, I know some people are already familiar with this, although for those who aren't, just so we're on the same page, the government funds R&D through various mechanisms, and one of them is known as SpaceWERX. And they fund R&D for different startups, in part because startups are a source of economic growth and innovation more broadly in the American economy. The DoD in particular funds the companies in part to gain access to that innovation and get more advanced technology and just tap into the innovative ecosystem of US startups that doesn't really have a parallel anywhere in the world to the degree that it exists in the US. And another reason why they help fund these companies is to expand the defense industrial base, just make sure it's more resilient, because the more suppliers and service providers that you have, the more you'll be able to weather any potential disruptions. Companies who are awarded a type of award known as a Phase 2 get an R&D contract to work with the military to produce prototypes. Now, companies who already win a Phase 2 can have access to a variety of post-Phase 2 programs run by the DoD, and it often involves collaboration with the private sector. These programs are meant mostly to help the companies cross the innovation valley of death and deliver their product to a military customer. Within the Department of the Air Force, there's AFWERX's TACFI and STRATFI, which I believe is the biggest one in terms of awards awarded and funds provided out of these three. The Army has a Catalyst program and the Navy has a Catapult program. I also believe that a lot of these programs are a bit agnostic as to which DoD Phase 2 contract you're awarded. So basically, a company that wins an AFWERX award from the Air Force could potentially apply for the Navy Catapult program, provided that they have a Navy sponsor for that project. Just to talk very briefly about TACFI, STRATFI, just very, very bird's eye view overview of it. They match funds anywhere between $375,000 up to $15 million. The matching funds options, TACFI is a bit more straightforward. It's just a 1-to-1 ratio. So as long as a company has at least $375,000 to bring to the table, AFWERX will match up to $2 million if the company has $2 million, whether it comes from the private side or from government contracts that are not these R&D contracts, the SBIR sitters. StratFi, it's a bit more complex, and I'm not going to get too into it because a lot of the companies here are going for TACFI, but basically companies just need to bring more money to the table from the government and or private side, and they're also awarded more money. So the TACFI funds, it's a 1-to-1 ratio. Company can get the funds matched if they bring money from the private sector, and that could be in the form of investment, it could be in pre-sales, convertible notes, royalties, IPO, so on and so forth, or any combination thereof. Or if they have government non-SBIR funds, that would get matched. And while companies are able to apply, or at least historically have been able to apply with just by having a commitment letter by the private funder or the government funder saying that they'll provide the money, the company must have the money in the bank by the time of the award. So as we mentioned, it's between $375,000 and $2 million in funding from AFWERX. So because that's matched on a 1-to-1 ratio, a company will end up anywhere between $750,000 and $4 million. With StratFi, it is because of the different ratios involved, a company could end up with anywhere between $12 and $60 million. I'm not going to get too into it, but companies for StratFi are able to get the funds throughout the course of the project, unlike TACFI, where the money needs to be there at the start of the project. So what's in it for investors? You can invest knowing that your investment will be matched. You get low competition on investment because the government isn't diluting the investment. We're not taking any equity here. You only need to really commit to invest at the time of the application. For if AFWERX agrees to match, you're investing in pre-vetted technology and in technology in multiple markets. And you're investing so the company can potentially deliver, should they complete their technology development, deliver to a tier 1 customer in the US government. From the Air Force partners, basically companies need to have either a customer and an end user. The end user is the person who would be using the technology at the end of the day, and the customer is the one who is in a position to make a purchase. And they both have to be ranked at least 06 or GS15 and up. This is for the DoD folks on here. Now, many of you probably not meeting that rank, but if you do like a technology that you see here and want to work with them, you have a couple options. One of them is just to collaborate with the company, work with them on a phase 2 contract, which doesn't have this rank requirement. Or if you would like to have your organization work with a company for TACFI, you could get your leadership involved to potentially support that contract. The end user position must be someone from the Department of the Air Force. The customer can be from someone from a joint organization, although they would have to explain why they are supporting a Department of the Air Force end user. Just very briefly about Army Catalyst, for those Army people on here or watching the recording. There's an initial award for up to $1 million with a 6 to 12 month period of performance. And there's subsequent enhancements that could be awarded throughout the 36-month period that require matching investments. Now that matching can lead to an additional $7 million from the Army SBIR organization, but that would require up to $3.5 million from an Army transition partner and another $3.5 million from a technology integrator partner. So that transition partner in the Army is the one who would be recommending and supporting the technology transition. And it's typically a PEO, who could also be Army Laboratories, Combat Commands, Army Material Command, or other relevant entities. And it requires integrator partners who are typically a prime or an OEM that directly and regularly works with the federal government to support technology transition. The last program I'll mention here very briefly is the Navy Catapult program. It requires a naval sponsor, would work with the System Command SBIR Program Office to nominate the project for funding. Match funding is encouraged, and the awards historically range from 1.7 up to $13 million. Here is today's lineup of companies today, all of which have won various Phase 2 awards. We're just going to start with PureCipher. We're going to go on to Critical Innovations, Legionarius, Celadyne, Phase 3D, Edmond Scientific, and then finish it off with InnoSys. And I will turn it over. We have a special guest here with us today, Lieutenant Colonel Vinny Pandy from SpaceWERX, who is able to share a bit more about TACFI and perhaps StratFi from AFWERX's perspective. So, Vinny?
Hey, everybody. Can you guys hear me and see me?
Yes.
Wonderful. Okay. Yeah, so I see some familiar names on the attendee list. So great to meet you guys. Michael, always good to cross paths with you here on these different webinars. And thanks to the team for having me. So I'm going to do a couple things here before I jump in. First and foremost, let me just state to the team here that I am active duty U.S. Space Force, right? I'm U.S. government. And more specifically, I am in charge of the Space Force's SBIR portfolio. So we have roughly $500 million a year worth of SBIR dollars, as as the team walked through earlier, and we execute that for the U.S. Space Force. As a Space Force person, we fall under the Department of the Air Force, and so I'm fairly comfortable talking about the way that the Space Force and the Air Force are using SBIR and specifically StratFis and TACFis. But certainly take any of my inputs with a grain of salt if your customer is likely going to be on the Army or the Navy or some other branch of the service. Okay. For those of you who are looking at the Space Force as a potential customer, I am going to drop a link in the chat here. And again, as the U.S. government and as the person in charge of the Space Force's SBIR program, that is my calendar link. Feel free to use it if you want to chat about and book some time with me directly before you apply for a StratFi with the U.S. Space Force. I'm happy to share that and with any company, just so you guys know where we're coming from. But okay, so we in the Space Force and the Air Force really are starting to use StratFis and TACFis as a tool to truly deliver operationally relevant capabilities. We're starting to actively pivot away from trying to use this as like lab demonstrations and simple tech maturation. And when we talk about StratFi, TACFi with potential net dollar amounts of around $60 million for companies that win those efforts, all of a sudden, right now we're talking about real operationally relevant capabilities that can be deployed into at least a demonstration environment with either the Space Force or Air Force customer or with the combatant or the component command users of your technologies. So I share that because that is starting to color how, at least on the Space Force side, how we review StratFis and how we rack and stack and prioritize them. So what I'll do is I'll walk through kind of what we look at in terms of StratFis and TACFis when I get them from the government program offices. I'll walk through kind of what some of the specific nuances of space only are, and then I'll open it up for a couple of questions. Let me just before I dive into that, let me just say this also: a StratFi or a TACFi application is not your company's application for funding. We view this as, and this is why we make the U.S. government customer be the one who actually submits everything, because we view this as a validated need from the U.S. government customer. So, yes, you're certainly probably pulling all the strings on the back end and putting all the paperwork and getting all the stakeholders together to make this valid. But from our perspective, we are responding not to a company's application, we are responding to the US government program office's need for a technology like yours. Okay, so when I get the US government program office's request to fund a StratFi or TACFi for one of your companies, here's what I look at. As I mentioned earlier, we care about operational relevance. So that means whatever your transition strategy is immensely important to me as I rack and stack and prioritize with my team. Transition means two different things, and both of them are equally important. The first is capability transition. I don't want this to be a one-off. I want something that is either going to, at the end of the StratFi, either deliver something that is operationally usable by the user, or by the government program office, or by the combatant command, or is now going to, or the tech is now going to mature enough that your technology is going to be part of a program of record or have a longer term revenue line from the US government on the back end of it. Which segues into the second piece, the definition of transition, which I care very deeply about. What is the US government's plan to actually fund your capability on the back end of it? This is not in your hands. This is entirely in your government customers' hands, but you can prompt the discussion with them early and often. So oftentimes I will look at one of the StratFi requests or applications that I get, and it'll hand wave over the financial transition. Like, what is your next source of revenue after this StratFi completes? And it'll hand wave over it and say, oh, we'll put a phase 3 contract in, or oh, we'll put an IDIQ type contract in place, and we'll get government revenue that way. That looks good on paper, but in reality, we all know that that is A, subject to a lot of risk in terms of, is the government actually going to fund anything? And B, there's no actual real commitment from the government on putting money behind that. So when you work with your customer on defining, the government customer on defining a transition strategy, let's talk about specific POM inputs, and I'm sure Brian and his team can walk you through what that is. Let's talk about specific unfunded requirements. Let's talk about specific avenues where you can see helping your government customer get revenue to then make your StratFi successful after it completes, to make a transition afterwards. Okay, then I look for customer buy-in. How actively engaged is your government customer? So oftentimes, and I'll share this quite candidly, oftentimes we have companies whose business model or whose phase of their company's growth necessitates a StratFi. And sometimes those companies kind of lead the horse to water with their government customer on trying to get a StratFi submitted. I fully understand. Everyone has to meet their obligations to their company and to their stakeholders. I get that, but what you don't want to do is drive the conversation too far for your government customer, because if I start getting a sense that this is largely something driven entirely by the company and less so by the government customer, that tells me that I'm going to have a transition risk on the back end. That government customer isn't necessarily going to live up to their expectations. So be a good advocate for your company, for your technology, to that government customer, and helping meet that government customer's needs. But certainly don't drive the conversation entirely and leave your government customer behind. Make sure they have buy-in. Okay, I talked about realistic government funding, so I'm good there. There was one comment I heard earlier, and when you guys were explaining what private capital means in terms of matching. I just want you to know, on the Space Force side, we also consider international government money as private capital. So if you are partnered with a NATO country or any of the friendly nations of Western, or any of the nations friendly to the US, and you have government money through things like NATO Diana, or any of the Norwegian Sovereign Wealth Fund, we consider those as private capital for matching purposes, which may help you because I don't think those take equity stakes in your companies. Okay, and then, okay, sorry, I'm just going through my notes here just based on what I heard earlier. Okay, and then for those companies that apply for as the screenshot showed earlier, there was both a dual use column and a defense only column for the type of Stratfire attack that you could submit, or your customer could submit on your behalf. If you're submitting for one that's dual use, one that you state has a potential commercial revenue source, then I'm very interested in also seeing what exactly your commercial revenue stream and plan looks like. We've seen companies that hand wave over and say we have a commercial application, and so when the Space Force and the U.S. government go into that StratFi thinking that we have disaggregated risk by the fact that you have commercial customers, and then on the back end we find out that the company doesn't in fact have a commercial revenue line. Now we've put ourselves in the situation of kind of bookending the entire company, and that's something we want to go into eyes wide open. Not saying it's a non-starter, but we want to go into that discussion eyes wide open about the role that government revenue is going to play in your company's growth versus government and commercial revenue combined. Okay, those are my big talking points. Then a couple of things I wanted to hit based on what I heard is I think the person before me was talking about how most of the companies on the line here are pursuing TACFIs versus StratFis. I just want you to know that last year in fiscal year 25 was the first year where we had multiple TACFI windows, which is good because it allows you as the company to not force your government customer to submitting a TACFI when they aren't necessarily ready to do so with you. So multiple TACFI windows is another opportunity to kind of line up all the stakeholders in the most mutually collaborative fashion, and then make sure that timing also works well for your company. For those companies here who are interested in StratFis, I want you to know that there is a pretty clear differentiator right now between what the Air Force and the Space Force are doing with StratFis. The biggest one that I want you to track right now is that the window to apply for StratFis is a hard cutoff for any of you applying for an Air Force StratFi. It's a hard cutoff, I think, early October, right? I forget the exact date. On the Space Force side, we also have a cutoff in early October, but our window to apply for StratFis will remain open. We are going to leave that open, and we're going to every few months just take another round of reviews on the StratFis that we have in the pot, and award things based on relevance and where our budget is. So apply by the first window if you would like to for the Space Force, but it's certainly not the end of it. I'm also not giving preference to any companies that apply by the first window, but not, and not to those that apply after the window closes in October. My goal as I evaluate Space Force StratFis during our October review cycle is going to be primarily to look at things that have a time imperative, meaning that there is a launch into space that needs to happen by a certain time, or there's something Golden Dome related, which may have some time exigency circumstances. And so those are likely the things that I'm going to look at for the first round of reviews in October. And then all the other missions, all the other technologies that apply for StratFis, in the first cutoff or after October, as we keep the window open, we're going to evaluate those on a rolling basis over the course of the fiscal year. Okay, the Air Force. Let me just foot stomp this. The Air Force is not doing that. The Air Force, if your application is not in by that cutoff in October, then you probably won't get another bite at the apple until next fiscal year. Okay. All right. I shared a lot of information. I'll pause there and I'll open it up for questions before I return the floor to Brian and his team.
Great. Thank you so much, Vinny. So yeah, if anybody has questions, I recommend raising your hand virtually on Zoom. It's under React. So when you do React, just raise your hand. If you don't see React on the bottom of your control panel, it might be under More, which is three dots when you click on React. And you could also always post in the chat as well. And it's not limited to just startups here who might have a question. I'm sure anybody from for the DoD or private sector who potentially wants to work with a company has a question, I'm sure Vinny would also be happy to answer any questions you might have. And someone wrote in the chat, are you going to, oh, okay. So someone was in the audience. They wanted to know if the calendar details could be posted because just a Zoom technicality was posted in the host and panelist chat. There's a chat that could be sent to everybody, including the attendees.
Done. Yep.
Perfect. I just have a question based on what you said. When it comes to the multiple TACFI windows, is there a specific budget for each window, or is there just a single pool of money, and then as companies apply, the pool of money just gets depleted depending on how many companies apply and how many are awarded within any given window?
Yeah, we're not gonna hamstring ourselves by saying that the first window has 50% of the budget, the second window has another 50%. We're pretty much gonna look at this as what are the strongest applications, and if they happen to get used up in the first window, then so be it. But that is not our intent, right? Our intent is to spread out the TACFI life cycle over the course of the fiscal year, because we know that our single cycle isn't going to line up with your business cycle nor your customer's funding cycle. So we're willing to do 0% in the first window all the way up to 100%, just based on the quality and the customer demand that we get. Because normally every time we get a TACFI or a StratFi, we also go out and talk to that customer and just figure out like where's your level of enthusiasm, and that factors into how much we fund per cycle as well.
All right, great. And just on that token, is there an estimate for how frequent these will be? When they'll start, when they'll end, or is that still being decided?
Yeah, so the StratFi one for the Space Force is just going to be open until the money runs out, and we'll announce when that happens. And there'll be a few different selection notifications that go out over the course of the fiscal year. For the Air Force one, again, it's going to be that single window, so that'll be pretty clean and easy to communicate. The FY26 TACFI windows, those details are still being worked out, but those ones, again, instead of like an open and continuous window, we'll just have a few more discretely compartmentalized application windows as opposed to the open and continuous submission window that we have on the space right now.
All right, perfect. We do have time for another question from someone else who's not me, if anybody has one. Although, I guess if you do want to talk to Vinny offline, you could also ask him, book a call with him.
So I got a direct message from Jennifer. Jennifer from InnoSys. She asked, can you submit, if we submit something in the area of Golden Dome but not meeting the initial October deadline, how soon do you think it might get reviewed? So the latitude that I'm retaining for my team is we're going to do one review in October, and then my guess is I'm not going to do another review right now until the FY26 appropriations happen, whether it's a long-term CR or it's an actual appropriations bill, because I want to see the government customers' money actually show up. And a lot of times government customers say that they're going to be using FY26 dollars on it. So, okay, I'll give them a chance to wait for the money to actually show up. So that's my forecast for when I'm going to do the next review, Jennifer. But if, for example, the October window hits and your company hasn't submitted, and you submitted on November 1st, and your customer, your Space Force government customer, tells me this is really important to them, then I'll do a November review cycle. I don't have to wait until whatever my previous plan was. So retaining maximum flexibility for myself and my team to react to our Space Force government customers and what their mission needs
are. Great. Anybody have another question? I guess we could do one more.
Yeah, if no questions, I'll start to close up with this. we are on the Air Force side actively pivoting away from trying to use SBIR dollars as purely research, purely lab focused customer bases. We are actively trying to pivot to things that have operational relevance, right? And so the closer your technology, the closer your packages can communicate that and demonstrate that, the better it'll be for us as we're reviewing your applications.
Awesome. Well, thank you so much, Vinny. That was really insightful. Really appreciate your time. And yeah, definitely recommend anybody to book a call with him if you want to learn more. So thank you very much.
Okay. Best of luck to all of you. Yeah.
Sure. Thanks. Have a good day. So with that, we're going to jump into our pitches. We're already a bit behind, but I do think it was worth it myself. And what we normally do in these events is we have the panelists introduce themselves before the pitches, but just because we are a little bit behind schedule, we'll have the company's pitch. And then when each panelist asks a question, or whoever has a question, you just introduce yourself very briefly before your question. That will be amazing. And with that, we'll go to our first pitch, which is PureCipher. We have Sam here to present.
Thank you, Brian. I'm going to get our deck shared here. Everyone can see my screen okay? Perfect. Awesome. Good afternoon. My name is Sam Berkson. I'm a project manager at PureCipher. Thank you for the opportunity to present to you guys today. At PureCipher, we develop artificial immune systems with a mission to secure AI systems for everyday life. Based on our core technology, we're developing autonomous cyber defense systems. One application of this that we're currently developing is the Multiverse Defense Network, AI-generated synthetic environments that are cryptographically indistinguishable from real network assets. That means that attackers can't tell if they're probing a genuine server or one of our synthetic decoys. In a layer beyond that, attackers can't tell whether they're monitoring real or synthetic traffic. While they waste time and resources, our system is studying their behavior, turning every intrusion attempt into actionable intelligence for defenders. And what really sets us apart is the foundation beneath this system. The Multiverse Defense Network is powered by our noise-based communication, or NBC technology, which we're currently maturing under an AFWERX Direct to Phase 2 SBIR award. Instead of relying solely on classical encryption that will be broken by quantum computing, NBC transforms data into high-dimensional noise. It also allows for steganographic obfuscation, allowing us to hide this noise behind images, executables, or any other file format. To an adversary, this looks meaningless, but to us, it's perfectly reconstructible and secure. And what we'll see here is our NBC system in action. So this is our chief scientist, William Hahn. In the top left, we see the raw video that we actually want to transmit, and then we're going to have a decoy video in the top middle. We're going to take the raw video and map that into our high-dimensional noise vector, which we see in the top right here. We then take that high-dimensional noise and embed that behind the decoy video, which is what's actually transmitted over the network. We can then take that decoy video, extract the noise, and then map that back into the raw data, in this case, the raw video. Now, cyber attacks cost a global economy over $6 trillion every year, with 95% of breaches going undetected for more than 200 days. And in this asymmetric fight, attackers only need to succeed once, while defenders have to be perfect. These traditional defenses are reactive and fragile, and with quantum threats on the horizon, they're even more at risk. Our multiverse defense network flips the equation. Attackers get stuck in realistic AI-driven decoys where they spend more time, gain less intelligence, and also suffer cognitive disruption. This also allows defenders to gain actionable intelligence on adversarial threats. This can also be turned into an offensive capability after you understand how adversaries are targeting your systems. And these aren't just static traps. The AI personas that we see chatting here in the demo on the right are complete personalities. They make decisions, respond differently under pressure, and generate their own network traffic based on those behaviors. That realism keeps adversaries engaged longer and convinces them that they're operating against real users and systems. Here you can see our AI personas having a conversation, and what we see on the screen now is the full background that we've constructed, for this persona. These personas can be completely AI generated or can take in various pieces of data from you as an input and generate the persona from that foundation. Meanwhile, defenders collect intelligence on attackers' techniques without exposing any real assets. I'd also like to point out that this is protocol agnostic and application transparent, meaning we can deploy this over existing infrastructure without requiring a costly system overhaul. The defense applications for this technology are broad, whether it's protecting autonomous systems in contested environments, securing edge computing deployments, safeguarding critical infrastructure, or defending real-time control systems. And commercially, it applies just as well to critical infrastructure, financial services, aerospace supply chains, healthcare, and other industries where security isn't just optional, but it's mission critical. And our traction reflects this market need. On the defense side, we currently have a $1.25 million DoD Phase 2 SBIR award. We're also in contract discussions with a prime contractor holding a $1.2 billion DoD award. We're also under DARPA review for other national security applications. On the commercial side, we've secured a letter of intent with an aerospace firm in the Boeing Honeywell supply chain, and we're also partnering in the gaming, healthcare, and financial services sectors. Our founding team brings deep expertise in business, cryptography, AI/ML, and cybersecurity. But what really strengthens PureCipher is the caliber of our advisors. We've been fortunate enough to work with leaders who've not only shaped technology strategy and industry, but who now hold or have held key roles within the Department of Defense and other national security institutions. We're proud to call Department of Defense Undersecretary of Personnel Anthony Tata a former advisor who can no longer legally serve on our board or any board since he took his post. We are also proud to have retired Lieutenant General Michael Barbaro advising us. Their guidance ensures that what we're building aligns directly with emerging mission needs and acquisition pathways. This combination of business and technical depth in the core team, paired with advisors who understand both the technology as well as the defense and commercial landscape from the inside, uniquely positions us to deliver impact at scale. We're now seeking $20 million in Series A funding, which will help us accelerate Phase 3 transitions, expand our commercial deployments, and strengthen strategic alliances across defense and commercial sectors. We're also seeking partnership opportunities to advance our technology's capabilities and market reach. Thank you, and I look forward to your questions.
Great. Thank you so much, Sam. So once again, if you have a question, just raise your hand virtually, as Joe and Marissa have done. So we'll just go in the order of the hands raised. So Joe, and if you just introduce yourself briefly before asking the question.
Sounds good. Thanks, Brian. Good morning, afternoon, everyone. I'm Chief Master Sergeant Joe McCrae. I'm currently stationed at Cannon Air Force Base in New Mexico, I'm the senior enlisted leader of the 27th Special Operations Communications Squadron, which is part of the Special Operations Wing and Air Force Special Operations Command. So I'm a computer programmer by trade, so software is kind of always naturally interesting to me. But any tech that can transform us and prepare us for the next fight like this is kind of interesting. It is always interesting and welcomed. So question, if you can say, Sam, your current SBIR Phase 2, can you say what unit you're working with?
Yes, we're currently working with Chief Kreider out of the Alpena Combat Readiness and Training Center, is our current sponsor for the SBIR award, which is for the core underlying NBC technology.
Got it.
Not sure if that correctly answered your question, but
yeah, that's great. I'll like to reach out to you guys.
Absolutely.
Possible. Thank you.
Yeah, both my email and our founder and CEOs are both on this slide. Please don't hesitate to reach out. We'd love to get in touch.
Great. Marissa?
How do you make it quantum resistant?
Yeah. Brandon, do you want to talk a little bit about the cryptographic background we've got behind the tech?
Sure. Yes, this comes to me, Brandon Langerberg, also co-founder on that slide that Sam presented. So we are using a combination of some proprietary encryption algorithms that we've created, along with the NIST standards post-quantum algorithms that are currently being standardized as well. I don't know if that fully answers the question, but I can go into more detail about it.
Proprietary. You're not building it on anybody else's tech.
I couldn't hear the last part. What did you say?
You're resistant. It's proprietary, right? You've developed it.
So, well, what we've actually done in it is we've used standardized algorithms from NIST. You can look at some of the post-quantum ones like Kyber and other sort of things that are considered post-quantum safe. And we've actually combined that with some of our proprietary algorithms. So we've actually used our proprietary algorithm and then wrapped that with some of the standardized algorithms on top of that so that it still becomes NIST compliant. So we have it's multiple different levels. We can go into more detail, but we use different type of techniques. We use the steganography discussions that Sam uses. In the back, everything is encrypted. So they have to first break through that or find, for example, for the decoy network thing that he described, they'd have to figure out which network the actual data is on. If we wanted to go further than that, they would have to realize that something's being hidden in the back. And then once they realize something's hidden in the back, then they'd have to decrypt. And they'd have to, in order to make it compliance, we've wrapped it with the standard algorithms that are out there that are considered quantum safe, specifically for the key exchange algorithms. But then we also use some of our own algorithms in combination with that.
Okay, because it's my understanding in my world that nothing is quantum safe at this time.
No, that's not entirely true. The algorithms that we have in place today, there's two sets of algorithms. There's some that we use for key exchange, which is to start the communication. The ones that the internet is using today are not considered quantum safe, and they need to be replaced. There's other algorithms that are out there that just store your information. Those weren't designed to be quantum safe, but it turns out that they aren't broken by quantum computers. They're reduced slightly, but still within an acceptable margin by quantum computers. So everybody is okay with those for the moment. But what the US government has done over the last 5 or 6 years is requested versions of algorithms that are quantum safe. They started a process in 2017. They completed that in 2022, 2023. That resulted in 6 post-quantum, or what we refer to as quantum safe algorithms. And they're currently in the process of standardizing those. The standards themselves have not been fully released by NIST, but they are online and you can access the algorithms and play around with them.
Great. I believe that's all the time we have. Somebody had a last minute question. But if not, Sam, if you would just put your contact information in the chat. I know it was on the screen, but just for the chat, that'd be amazing. So people could reach out to you or after. And with that, we'll move on to our next presentation, which is critical innovations. And we have Ross here to present.
Great, thank you so much.
Thank you.
Okay, hopefully everyone can see my screen now. Okay, yeah, so I'm Ross Donaldson, President and CEO of Critical Innovations, here to talk about our fully qualified manufacturing technology. So as many of you may be familiar with, the problems with traditional manufacturing, which are centralized and vulnerable with heavy logistical chain issues, especially if we're imagining ELSCO type combat operations. There's long lead times, leads to obsolete parts, difficulty both domestically and internationally getting the parts, either whether or not these are replacement parts, for example, for the Air Force, or whether or not we're talking about distributed manufacturing, for example, in future Golden Dome operations. If we instead look at what would on-demand decentralized logistics look like, that essentially would be the production of components or parts, whether replacement or initial unique parts, at the point of need. So wherever that location is, suddenly we have assured availability, on-demand production. It's more scalable, it's more secure to have that. So what is the current problem and why don't we have it? So if you look at, for example, just parts for aircraft, you can see that there are all currently multiple different parts are being capable of being made via additive manufacturing, and that list just continues to grow day by day. And yet we don't have distributed manufacturing at the moment. The problem with it is not necessarily the production of those parts, but currently we have a major gap in the qualification of those parts after production. So if we're using a good manufacturing process, for example, under AS 9100, which is for aerospace, you can make that part, but then what happens in-house is you have an inspector who goes in and inspects that part, makes sure that it is meets all of those quality requirements. Obviously, nobody's going to put a part into a spacecraft or an airplane without knowing that that part meets all the needed requirements. As I mentioned, there are a whole bunch of strict regulatory requirements, and FQM is really focused in those industries, whether or not it's aerospace or, for example, medical, that have a bunch of requirements on the quality side. So although we can 3D print them, we currently need inspection, again, at those centralized locations, which keeps us from being able to do distributed manufacturing. So what is FQM? Essentially, it's a system that allows both the additive manufacturing production as well as qualification in the system itself at the point of need. So this increases the maintenance capacity if it's for maintenance. If it's for production, for example, Golden Dome, it allows immediate production of that at those points of need. So what's actually happening in the system, in addition to just the standard kind of CAD instructions that a normal 3D printer has, in addition to that and how to make that, it also needs to have the inspection and testing requirements and the initial software part that goes into the machine. Then the machine by itself, although it's agnostic for the type of printer, we adapt these printers to allow them to have both in-process and post-process inspection and testing throughout the process. That then leads to a final report and a fully qualified part. Importantly for a quality system, it has 100% data persistence and gives each part a unique part or lot number, which allows it to fit into a standard quality system. So here's an example of making just a particular widget. During pre-process, you have the CAD files, as I mentioned. During the process, you have a whole host of sensors in the system, including an integrated scanner, a bunch of temperature sensors, vibration, etc., that are making sure that the print is going according to process. Then additionally, at the end, you have a bunch of testing that can go automated in the system that then provides an automated qualification analysis. And I think this is the key part. In addition to producing a certified for ready for use part, it also rejects and quarantines uncertified products. So just like it happens in a good manufacturing process. To date, this all started with a $1.7 million direct to phase 2 Space Force SBIR. We since that point have had an additional $3.6 million from the U.S. Army and have just been selected for award for a $4.2 million award from ARPA as well. At the moment, what we're seeking for is Department of the Air Force, either Space Force or Air Force customer and end user for use in a TAC-5 submission. We already have the additional matching funds and are looking for those customers and end users. This is a bit about our team. So we are really at the edge of this engineering innovation. Government contract compliance, we've had over $100 million worth of funding from the US government, and quality standards really fits in perfectly into what we're doing for this project. Here's some contact information for me, and I'm happy to take any questions.
Great. Thank you so much, Ross. So once again, opening the floor to questions. If you have a question, just raise your hand virtually in the React button. So either directly on the bottom of your screen or under the More option, the 3 dots for More. To react, raise your hand. But I guess I'll just kick things off, Ross. Would you maybe mind speaking a bit more about some of the work you've been doing with the DoD so far on your various projects that you alluded to earlier?
Yeah, looking specifically in this area. So the initial part was from the Space Force. So that was looking at production of this technology for similar to kind of a Golden Dome type production on space aircraft. Additionally, the system by itself is agnostic to exactly what's being produced. So we have a different project with the Army that's been funded for essentially making surgical tools at the point of use, essentially in the far forward environment, because those have to be FDA regulated. So they're parts that will meet all of the FDA regulations when they come out. And then similarly, the ARPA award is looking at additional kind of civilian use case in a similar manner of producing parts that are also regulated, highly regulated under quality systems, including the FDA, but can be produced in a distributed manner, still under control of us as the GMP central manufacturing, even though the production of it is happening in a distributed manner.
Great. And did you have anything for mind about what you wanted to do on a TAC-5 project? Should you be awarded?
Yeah, I think so. You know, we've had a very successful initial Space Force SPIR. We've now had a bunch of traction both from the Army and ARPA. Looking at kind of the medical components for a TAC-5. We'd like to circle back and to specifically either if it's an Air Force or Space Force need, focusing on likely on production of either distributed manufacturing, for example, the Golden Dome parts for if it was Space Force, or for the Air Force, there's a huge need for replacement parts that we'd like to focus on for that ability to make replacement parts at a point of need and time of need.
Great. We do have time for another question if anybody else happens to have one. Just give that a moment. But if not, for now, Ross, if you would put your contact information in the chat, maybe someone, if somebody has a more in-depth question, they could reach out to you to ask and learn a bit more about what you're doing. But thank you very much.
Thank you, guys.
For your presentation. Awesome. So with that, we'll move on to our next presentation, which is Legionarius. We have Alex here to present.
All right. Well, thank you so much, everyone, for taking the time. My name is Alex Brunzig. I'm the co-founder of Legionarius. And so we're focusing specifically on the warfighter. And over the last couple of years, we've been working with SOCOM, AFWERX, SoftWorks, 7-Eleven's Human Performance Wing, and others to create sensors directly that can be printed directly onto garments. So basically, we're taking a regular off-the-shelf dumb garment and making it smart. And of course, use cases are quite, there are quite some different scenarios, from just printing data highways and power right into your garment, or even antennas. But we specifically focus, because we have some medical background, we always wanted to focus specifically on the entry teams, the ones that when injuries happening that hemorrhaging, penetrating wounds are the number one cause of preventable combat death. And so just being able to determine if someone is injured, if someone is shot, shrapnel or something, that we can take the information with the vital signs, we detect that someone is injured, and combining this and directly feeding the information right into ATAC and Bad Dog and other systems. It automatically pre-populates a TCCC report and basically speeds up the process. So you immediately have the situational awareness from a tactical point of view, but also from a medical one. Yeah, you see some prototypes in the back, but I wanted to show you a quick video from one of the tests we have done, and you'll see some end users using that, doing a CQB event. And so let me see if I can. All right, let's see. Share. All right, so that's a brief video, and so we have 4 guys here. These are the call signs that you see, green, blue, silver, red, and then you see the ATEC screen. So this is what our screen looks like.
Man down.
And
Good hit.
immediately you can see on the lower side, call sign green injured. So the entry person was hit with
Contact right.
and the rest of the teammates are now conducting their mission. Basically, on the command side, you can already see
moving.
You can open up. You can see heart rate and respiratory rate of the injured person, and it automatically pre-fills TCCC report card.
Clear right.
Clear left. All clear. 2 Eagles coming out. 2 Eagles coming out. Blue.
Yeah. So this has been so basically all these team guys here are wearing. So all the shirts that you see here have these printed circuitries in them, and yeah, so now we see them. Gazarak here with one of the wonderful Suburbans we are finding. Riding into the sunset. Yeah, so this is now this particular use case is in TRL6. So we've integrated with the Air Force's system, ATEC, and their medical side, BADOC system. But once again, like this is not just for the medical portion. We also, do other things. Like if you can see here, for example, we're working with, this is like outside DoD, but more on the sports fencing side, where we work with partners that want to, make the regular sports garments sensing, giving them sensing capability. And now this is a little bit more for showcasing. They want to see like lighting, etc., where you are hit. But we're also working with PO Soldier, and the more I'm seeing what's going on there from a data perspective or power perspective, I think we might have some solutions there as well. Also, when it comes to just like flexible antenna designs that could be woven right, that are being basically part of your garment. All right, so that's kind of in a nutshell. We'll also be at AUSA, so because we had the honor of participating and winning the X-Tech Surge 6 competition with the Army, they are giving us another booth as alumni there at AUSA in DC next month. So in case you're there, would love to meet in person as well.
Great. So we'll open the floor to questions. So if anybody has a question, raise your hand virtually on the React button, and then we'll call you in the order of hands raised. So we'll start with Marissa.
Hi, what's the name of your company?
Legionarius. I'm gonna drop my information here in the chat in a moment.
Okay.
Yeah, so we're so I'm right now I'm in Massachusetts base. I'm just outside of Boston. Yeah, I'll send the details here in the chat in a moment. Okay. For sure.
Michael. So that was a hand raised by Michael Wagner.
Hi, yeah, I'm sorry. I'm Staff Sergeant Wagner with 2nd Air Force Detachment 2. We head up innovation projects for tech training to include like AFWERX. So I think this would be an interesting use case or something for us to use in the training environment before sending it operationally as well. So if you can send me your contact information and stuff, that'd be great.
For sure, yeah. Thank you so much. No, that would be a great opportunity. Thank you.
All right.
Great. We have another question from Timothy Anderson. And you are muted, by the way. And just
thank you.
Ask before, just introduce yourself briefly before asking.
Yeah, this is Captain Anderson from Naval Information Warfare Systems. Navy Captain, vice the other branches. It's a little different. My question would be, can you do this system in larger panels? So for example, if I've got a large unmanned surface vehicle and I want to monitor different specific critical locations for damage, and I want to have this capability in the bulkheads of those specific spaces, I can have that and get regular reports on the status and detect damage and know the state of the ship.
Yeah, so the printing itself is really, it doesn't really matter what type of base material it is. So I've done, for example, somewhere here in the background, I'll probably find it. I had a request one time asking if I could print something on a wing structure. So I built a fixed wing model, and then we were shooting it down, and you could see immediately the hits, the holes happening on the wing in ATAC. So we just had it directly pushed out. So yeah, would love to learn more, because it depends a little bit, of course, on the temperature ranges. Would it make more sense to have something on the outside, on the inside? Like, how is it exposed to? And then, what kind of damages are we looking for, right? But yeah.
Sure, and by extent, and to extend that just a little bit further, I'm assuming you could do, industrial vehicles, civil engineering support equipment, other large things that are operated remotely, and we want to monitor the status of.
Yeah,
it sounds like there's a lot of opportunity there. So well done, thank you.
Yeah, thanks so much. And to be honest, like, it's even easier if I don't put it on a person. The person is always the one that is going to tell me, like, oh, this is scratching a tiny little bit, or this is not as I'm used to, like just a regular shirt, even though it feels like almost as much. So it's even easier.
Fantastic, thank you so much.
Great. And we have our last question from Mike.
Mike Telside from Los Angeles Air Force Base, Space Sensing. My question is, how are you doing the communication to send the data? Are you using your own proprietary process, or do you need to integrate with whatever unit that you are serving?
That's a very, very good point. So we have there multiple pathways. Initially, because when we started working with SOCOM originally, every one of those teams have their own radio equipment, right? Your MPU-5s and whatnot. And so for those scenarios, we just plug directly in. And so we have like we have a literal plug that you can plug right into like your Net Warrior system network. So there's not even a power requirement. We just take a little bit from the conformal battery and we just tie right into it, into ATAC. We have a plugin on DoD site. You can download it and just go from there. For the scenarios where we have only, let's say, one person with a tactical radio and 40 guys running around, and you still want to put some sensors on them, we also have some small mesh modules that we developed, and also sometimes also in partnership with others like GoTenor or so. You might be familiar with them. And so we're partnering up and then basically offering like a small package that could give you like some mesh capabilities for low data volume. Again, that's not giving you an MPU-5 throughput. That's just like giving you a sensor status every 30 seconds, every 3 minutes, or whatever you need, right? In a secure network. And then from there, it's getting backhauled through your tactical radio out.
Great. I believe that's all the time we have. Thank you so much for that presentation. And please put your contact info in the chat. We'll know where to reach out.
Thank
Thanks
you so much.
Sure, thank you. So with that, we're going to move to our next presentation, which is Celadyne. Just a note to the panelists, in terms of the hours, we're going into an hour at the end. So for those who sign up for the first hour, thanks for joining for that. And if you still want to stay, we're not going to kick you out. We're happy to have you stay. For those who are on for the whole event, obviously, happy to have you stay as well. For the panelists who joined for the second session, the second hour, thank you for joining. What we're going to do is we're going to have you introduce yourselves as you ask questions to the companies in the Q&A portion. So thanks for those who joined, and without further ado, we'll get into Celadyne's presentation with Gary.
Hey guys, I'm Gary Ong, founder and CEO of Celadyne. So quick 5 minutes here. Sorry for the background here. I'm actually in Houston pitching a bunch of our potential investors. So I'm going to talk to you a little bit about hydrogen. But before we go there, I guess I'll start with a quick story about what keeps me up at night these days. So this is directly from a publication out of China. So the development of new energy technologies, including hydrogen fuel cells, will provide a strong foundation for the modernization of our military logistics and equipment. So what I see is that continued technology development is crucial for military readiness. And we made the mistake of not investing in solar back in the day. We made the mistake of not investing in lithium again. And this time, we're about to make the same mistake, just that for hydrogen technologies. Toyota has already basically sounded the alarms. A bunch of other people in the field are talking about it, but most other people who are not in this don't talk about it. So why is that relevant also on a commercial standpoint? Well, you have defense materials, heavy-duty transport, industrial decarb as clear things that are important. But after noticing that, at least I decided that, you can't have that happen. So we decided to build technology that would make basically the best hydrogen fuel cell electrolyzer technology available in the US. So the company is completely domestic based. We manufacture in Chicago, Illinois, as well as Rochester, up in New York. Our customers are all out of Michigan. This is what I can get you. A fuel cell that's 5 times better. So 20-year lifetime. An electrolyzer that's about 40% cheaper off the bat, on top of a 20% improvement in efficiency. That basically lets you make hydrogen at the edge, almost as good as a typical steam methane reformation plant, and get to the right cost targets and the right volumes. Now, why is that important? So the company was founded in 2020. Our main traction is dual use across automotive, grid, as well as defense. $1.9 million Army contract through the SBIR program, 50 kilowatt fuel cells for unmanned silent systems. Think Silent Watch. We also got a 1.8 with Raytheon as funded by FSOC Special Operations. And then on the grid side, we finished a pilot with National Grid and have a intention to deploy a 1 megawatt pilot with Southern Company in 2 years. So with that said, the team is myself and most people coming out of Argonne National Lab, DuPont, Fiat Chrysler, Advanced Ionics, the Naval Research Lab. Pretty serious about making this thing happen, all American citizens. And the funding to date for the company spent about 10 million, 4.5 is private capital. The other 5 plus is either from the DoD, ARPA-E, NSF, or basically all the main research funders. The private Series A right now, 12 mil, over half committed. The TechFi opportunity I'll talk to you about right now is the 1.9 matching funds. The scope of work I want to do is to expand our work on one of 2 things. We're negotiating who's going to get this TechFi. Either the Space Force will get it for small modular fuel cells, or the Air Force will get it, which is the 10x better fuel cells for advanced UAS, the kind that can carry like 50 pounds and travel like 200 miles. And with that, I'll be happy to take any questions.
Great. Thanks so much, Gary. So opening the floor to questions, especially for those who are new. The way you ask questions is you click React, raise your hand on the React. React button is either right there on the bottom of your control panel, or if you don't see it, you click on More, which is 3 dots, and then go to click React to raise your hand, as Andres did. So Andres, if you just introduce yourself briefly and then ask a question.
Thanks for the presentation, Gary. My name is Andres. I'm an investment associate for Allen Ventures, which is the corporate venture capital for Lockheed Martin. Sorry for just ask for a quick repeat. Did you say that you were raising your Series A right now, and then you're well on your way and getting that funded?
Yes. So we're raising Series A. Started about 2 months ago or so. Securing the final lead term sheet sometime this month / early next month. Over 6 committed from CBCs mostly. But if you want to have a conversation about the private Series A, I'll leave my information in the chat, and feel free to contact me about that too.
No, perfect. Thank you so much. I appreciate that.
Planning to close around by the end of December, just so that you can kind of get the timeline.
Perfect. Thank you.
Great. We have time for more questions if anybody has any. Sarah?
Hi, Gary. Good to see you. Can you talk a little bit more about the product line and how productization is going?
Of course. Yeah, so there are clearly two products, right? Let me just go back to this. The fuel cells and the electrolyzers. The fuel cells, we work with the integrators to put into the final fuel cell because the fuel cell has to be tied to the final application. Think of it as like a truck fuel cell doesn't look like a car fuel cell and doesn't look like a UAS fuel cell. So because of that, we sell the membranes plus the membrane plus the catalyst on there, and then we work with them to integrate it into the final product. Short version is sell membranes and catalysts on the fuel cell side. On the electrolyzer side, we build either the electrolyzer stack or the full system. And then after that, we ship that to our final customers. So for instance, the National Grid one, pilot, that was a electrolyzer that we built. We actually just got a LOI for 100 units of small electrolyzers for like as a subcontractor for like DLA. That one's also going to be electrolyzers that we will also build.
Great, thank you.
Great.
This is Alex Hamilton. I'm in the airport, so I apologize if I didn't raise my hand properly.
How are you, Alex?
Alex Hamilton with Craft Capital. Quick question: you're doing the raise. What's the pre-money value?
So my investors want to give out about 20-25% of the company at most. My guess is a 12 mil raise, valuation is going to hover somewhere between 40 and 50 post.
Understood. Thank you.
Of course.
Great. We have time for a last question if anybody has one. I could just ask Gary. So could you maybe just expand a bit more about some of the work you've done with the DoD before this, and also get a little more in the details about what you plan to do with the TACFI award?
Yeah. So the company actually was founded, we started, the first commercialization of the core science came from Air Force. They were our first monies in. After that, Shell Ventures was the second. The whole point here was to solve the critical problem that has killed a lot of fuel cells and electrolyzers, which is membranes and catalysts. Make something that's really good on the material side and then expand forward. We finished developing that material in 21-22, developed our first 100 watt fuel cell for the DoD, for US Space Force. That's done. And then after that, Army heard about us and wanted to do the 50 kilowatt project. That's the one that we will deliver by the end of the year. Then Air Force came back, specifically Special Operations heard about us. And then so now we're delivering materials to Raytheon to put into Raytheon's fuel cells so that then Air Force can get those fuel cells. And the latest one was the electrolyzer one. That one, I don't know how DLA heard about us. I guess they heard about us to the Air Force. And then after that, they needed small electrolyzers. And then so now we're going to deliver electrolyzers to DLA.
Awesome. All right, that's a pretty nice flow so far. Hopefully, success continues.
Hopefully, if there's anyone here that's in the Navy that wants to chat though, happy to take that chat too. We have engagements with NRL and ONR and like Collins, but then that's the only branch of like the military that we don't have an active contract in. But if anyone wants to chat about that, happy to take that.
All right, great. So yeah, anybody in the Navy in the audience or who ends up watching this presentation recording, definitely, well, anybody from the DoD really reach out, but especially the Navy, if you want to get Celadyne integrated into some of your systems. Well, with that, Gary, thank you so much for your presentation. If you put your contact information in the chat, that'd be great. People know where to reach out. Thanks for bringing the good energy with your pitch. And with that, we'll move on to our next presentation, which is Phase 3D. We have Niall here to present.
Hey, everyone. Great to meet you. Thanks a lot for the opportunity, Brian.
Sure.
Awesome. Okay, let me just pull up the deck. Sorry, I'm in the car in the parking lot from a customer. So please excuse any kind of background noise I got going. All right, can you guys see this? Yep, great. All right, so I'm presenting on behalf of Phase 3D. I'm the CEO and founder, and we're working on Bourne qualification for advanced manufacturing. Solving is U.S. manufacturing. We've heard from the Marine Industrial Base, the Air Force Sustainment Office, the Army and the Marines that we need to 10x the speed and capability of advanced manufacturing for defense by 2030. It's a huge push from the primes, their supply chain. The efforts to onshore manufacturing is really huge. Specifically, additive manufacturing has growing costs for qualification, proving that these advanced manufacturing parts can be used in production. Certification and qualification costs are estimated to increase to $8 billion by 2030. And in general, advanced manufacturing, there's a ton of opportunity to reduce the unplanned downtime from systems that are needing to be replaced or printing defective parts. The solution, as we see it, is AI-empowered qualification, starting with vision systems in terms of hardware, an AI prediction platform that collects data and is able to automate qualification. So it's kind of turning the whole part certification of advanced manufacturing on its head, using advanced vision systems and data correlation in the middle to automate qualification on the back end and even influence optimized design parameters on the front end. The solution that we've developed is called Fringe Inspection. We focused on metal 3D printing industry. The sensor attaches to the metal 3D printers and it measures parts during the printing process so that we can eliminate or reduce the downstream costs for qualification and certification. It uses AI patented software that collects data and compares the real-time data to previous cases where real-time anomalies created parts that fail. And basically the impact for customers is that by collecting real-time data across advanced manufacturing, like additive manufacturing, solar panel manufacturing, battery manufacturing, you can eliminate or drastically reduce the qualification process, which is needed to prove part quality. And with those paired data sets, you can even optimize planning and design. For example, using metal 3D printing to print parts faster because you know that they will have high quality on the back end. This is our traction so far. This year, we've gotten over $1.5 million of POs for installing and licensing software, installing our sensor on metal additive manufacturing machines. We've done $4 million in revenue over the past few years with very high margins. And every time a customer installs our technology, it comes with a software license that renews, that fuels our software as a service business model. We've been in the market. We have a pipeline value of over 2.6 million. That spans across aerospace customers, Navy and Navy supply chain customers, research and development companies, as well as contract manufacturers that print metal 3D printed parts. We have a great quiver of companies that are using our system today and paying us to develop our system for their machines tomorrow. Across the supply chain, we're a built-in option on several major metal 3D printing companies. We've worked directly with the end users of the technology like GE Aerospace, Naval Nuclear Lab, and other aerospace production companies that need quality at the tip of their fingertips instead of only from an X-ray about a month after the parts print. We're also directly the institutions like NASA, the Navy, and the Air Force. We have a couple machines installed at the Air Force, at the Rapid Sustainment Office, a machine installed at the Navy Danville Center of Excellence that's printing parts for the Marine Industrial Base production parts, as well as NASA that are developing copper metal 3D prints for rocket engines. This is our ask after a ton of success in SBIR-funded R&D and deployments. We're looking to match our current round with a TACFI matching to mostly support USAF Rapid Sustainment Office and start collecting the data that they need to eliminate costly post-inspections for their part quality. We're also open to NAVAIR, NAVC, as they're engaged in a lot of additive manufacturing. Some information about the round before I close it out. We have a lead. They've committed 1 million, and so we're looking for the second half in strategic capital or other VC investment. Thanks, everyone.
Great. Thank you, Niall. So we'll open the floor to questions. Once again, if anybody has a question, just raise your hand virtually through the React button, which is either just on the bottom of your screen or under More, and then you go to React and click Raise Your Hand. Do have somebody from the audience. Guess I'll allow you to. Well, first we'll go to Sarah Jones, and then maybe we'll get Justin from the audience to ask
Hi,
a question.
Sarah Jones from InQtel. So my question is really about kind of twofold. How easy is it? Like, what kind of upfront effort is required to install your sensor on the machine? And then two, like, what in terms of how much collaboration do you need from the OEM in order to, you know, have your product, your hardware be compatible? And like, kind of, how are you guys thinking about that partner go-to-market strategy?
It's a very good question. Thank you. So over the past 2 years, we've been successful with building retrofit inspection systems. And so we can connect to these metal 3D printers and through Windows. And so we've been able to give our aerospace customers the data that they need without going through the metal 3D printer OEMs. That has gotten the market traction and the market recognition to use as a pull strategy for the metal 3D printing OEMs who are now partnered with and are now shipping our systems on their printers as a standard option. And the 3D printers, they get the data to improve their prints, as well as the competitive advantage for their customers, giving them the ability to qualify these components for DoD and other highly critical applications. So it's really, you know, as a company, we're transitioning from the retro where we're able to showcase our technology to a channel partner where we focus on the data collection, licensing data sets, and software as opposed to the sensor itself.
Okay, great. And Niall, just your bandwidth is a little low, so maybe if you would turn your camera off, because it cut off a little bit here and there, just so we could hear you more clearly. We do have a question from Justin Martin from the audience, so I'll allow you to speak if you would like to ask a question.
Do you hear me all right?
Yeah.
Okay. I was just curious. I heard, you know, talking about metallurgy and whatnot, but what about components that have systems of systems that are also critically short of supply, like transformers or chips, or, you know, do you have any successes there to share? That's it.
Yeah. Question really, you know, the larger deck shows that 3D printing for critical industries as our the service of addressable market. We found the capability gap and the need and very low in that market. The adapt printing sensor to other kinds of advanced manufacturing like sprays and coatings, which we have done a deployment for the Air Force to cold spray, things like ceramic that is Air Force, things like powder vapor deposition, battery coatings, and solar panel manufacturing.
Oh, it looks like he would cut out due to bandwidth issues.
Maybe just put it in the chat. I couldn't hear what he said other than powder coat. I got an idea of what he's getting at, but anyway, it's no one's fault.
Yeah,
I'm in the middle of nowhere in the car.
Yeah, no problem. Niall, maybe it'd be best just to answer in the chat.
Okay. Yeah, I turned the video off and I stopped sharing, so maybe this will be better.
Okay, yeah, we could try this.
Yeah.
For now. Yeah. So do you want to maybe re-answer the question quickly?
Yeah, Justin. So essentially our beachhead market has been metal 3D printing. We developed the hardware that is really exceptional at measuring these thin layers. We see similar kinds of manufacturing in the solar panel manufacturing, sprays and coatings for battery and medical gaskets. So that's where we would expand past additive manufacturing, and then using the business model of collecting real-time manufacturing data, collecting the impact of that data with whatever qualification and post-inspection, we'd be able to really transition to a data set ownership that helps those customers reduce the cost of qualification on the back end and also improve the processing design at the front end. So, we've been in the 3D printing market, but we also showcase the technology in sprays and coatings to kind of prove that, the technology is applicable to other non-3D printing markets.
Okay, thanks.
Yeah.
Great. Well, that's all the time we have now, but thank you so much for the presentation. And, despite the it being under circumstances of travel, still pretty good, even with the challenges of communication signals. But yeah, if you would leave your contact information in the chat, that'd be great, so people know where to reach you if they want to learn more. And with that, we'll move on to our penultimate presentation, which is Edmond Scientific. So whenever you're ready, I believe it's John. Yeah, John.
It is, Brian. How are you?
Oh, wow, I'm great. Great. Happy to see you.
My name's John. I'm the president of Edmond Scientific, and we're going to talk about some laser optical communications technology that we've been developing. The challenge is laser does not penetrate clouds, fog, or particulates. For those kind of conditions, that RF is used, and RF has large side lobes, back lobes, easy to detect, not so covert, has some vulnerability. Laser obviously produces much more better fits, higher data rates and stuff like this, but it doesn't penetrate clouds, fogs, or rain particulates very well. So what we've done is we believe we have a computational photonics technology that we've been demonstrating, and how that works is it basically creates what you could in lay terms call a virtual coax cable. So it splits the signal, it creates a outer shell and a shock wave that clears particulates out, creating a center clear channel that has low index of refractions to be able to have a signal. What that looks like pictorially is like this. Our effort was in laser satellite communications, that's space to ground, air to space, ground to air. However, for our Army partners on the call, that's also battlefield smoke and obscurance clearing. You have shorter ranges. So for laser target detection and tracking, you're able to clear tuned nanomaterials and other things from the battlefield to be able to get a clear channel for your laser spot. What the laser looks like in the lab is like this. This was a phase 2. And this is the laser going through a 1 meter long cloud chamber, right, where we were generating rain and fogs and things. But purpose of our phase 2 was to do an outdoor range test. So here the results are of what the lab configuration was. All these optics in the center are the optics that would be retrofitted to any existing optical communications terminal or ground station and things like this. So our solution is an optical solution with signal processing. We're not building lasers. We're not doing stuff like that. We're retrofitting with an optical and a signal processing front end. So from the bottom right, you'll see the bit error rate was basically your communications loss. In the cloud and the cloudless environment, we had a bit error rate of 0. You do get some power loss as you're going through, but that's affecting more the range rather than the bit error rate. And the purpose of the real life outdoor range tests was to see how all of this lab practicality theory translated in the real world. We were the 52nd Communications Squadron, of which Master Sergeant McRae was instrumental in connecting us with, is there in Spangdahlem, Germany. We were scheduled to do an outdoor range test there with a high energy laser. The range that we were setting up looked like that. There was our pad where we were putting the laser. We have equipment we were buying and setting up. That was on the transmitter side. This is on the receiver side. And we ran into all kinds of problems. So the problems we ran into is how do you get clearance and approvals for high energy laser test on an operational Air Force basis flying fighter missions in Poland, Romania, in Eastern Europe? We'll be asking them to close down flight operations for sequential night periods. You have personal safety. This was a 1 terawatt laser. So we were looking to generate a filament about 180 meters long to penetrate clouds fog. We needed to wait for bad weather. You've got some downrange safety issues. You had some host nation Germany approvals on environmental and laser safety. And the main problem also was applied science is not the 52nd Communications Squadron's main focus or their understanding. They're supporting F-16 operations and supporting a applied science test wasn't really something that they started losing interest in. Also, they misunderstood the basics as we brought in the high energy laser equipment, cooling, power, and stuff like this. They didn't feel that it met the mission need of being transportable, light for deployed operations. And we tried explaining that we weren't building the laser, we were building the optics, but we had gone too far apart. We were flexing to a different range, the TISTF down here in Central Florida, or the Naval Research Lab Chesapeake Test Range. But the problem with the existing ranges is getting approval to shoot lasers in rain and clouds. You have the scattering issues and hitting raindrops. Most ranges are not approved for shooting high energy lasers in bad weather. And we were still using scientific lasers and didn't have actual MIL-SATCOM or field laser systems for testing or testing the optical communications. So we ran into all kinds of problems. We ran out of time. And what we're looking for the way forward here on the StratFi TACFi is really a partner to be able to obtain use of an optical ground station and a range. We are still looking to be able to get a range that we can go out 1 kilometer or 5 kilometers. The ranges that we would support bad weather at the Chesapeake Test Range or the TISTF at UCF. We'd like to be able to do a vertical shot through the clouds up in the atmosphere. That requires special range considerations, obviously. Fallback position would be a horizontal test in simulated rain if we're going in the desert, like in New Mexico or something like that. But that's where we are, and we're looking to still advance it and get some real world data. There's a lot of physics that still needs to be collected on the attenuation, the coherence and things like that, post-cloud, post-rain, as well as the developing the algorithms for the effectiveness of the signal as it loses power and what bit error rates for planning purposes. And that's all we have. I'm able to take questions.
All right. Thanks so much, John. So opening the floor to questions. Once again, if you have a question, just click on the React button and then raise your hand virtually. If you don't see your React button just on your control panel, you could probably under more, it's 3 dots more. So you click that and find React and raise your hand as Lena has done. So, if you just introduce yourself briefly and then ask your question.
Sure. My name is Lena McDonald. I'm with Outsiders Fund, a VC firm based in New York City. A couple questions here. The first is, trying to understand the long-term development plan here with regard to ground stations. Given you all are shifting the communication protocol away from radio, which all ground stations right now are predominantly built for, are you going to need a whole new set of ground stations built to be able to communicate with this new system?
No, Lena, we're using existing, I mean, there's not many optical communications ground stations, right? Or optical communications terminals, OCTs. So the whole idea is you're putting that laser optical front end in front of what exists, and you're shaping the signal, you're creating that vortex. And then you're doing the signal processing on the back end. So we would not disrupt existing supply chains. We're not really developing a new product. We're looking to provide an optical modifications and software modifications to existing product lines. But there's not many that exist out there for, most of it's satellite to satellite communications, or even the deep space communications are shooting to one of 3 places in the world that are Canary Islands, New Mexico, everything where there's no clouds and no rain and stuff like this. The use case that Air Force was interested in was being able to download air tasking orders in the German, Northern European environment in less time, to not get targeted by counter-targeted with drones and other kinds of things, as well as be able to communicate to UAVs and uplink, downlink kind of stuff in bad weather. So that's what we feel we'd be able to do. With the Army scenario, it would be battlefield obscurance, but no, not a new product, just a new technology for modification.
Thank you.
Great. We have time for some more questions if anybody has any. I could just ask, John, would you mind speaking a bit? Oh, never mind. I'll put that on hold for a bit. We have Devin ask his question. Devin?
Hey, this is Lieutenant Colonel Devin Beckwith. I'm with Special Operations Command. One thing I'd be curious to know here is how many other people are doing this kind of technology development on optical modification for either laser comms or energetics to go through weather. So really, it's like, who's your competition and what sets you apart?
So, Devin, this is really still in the lab. There's only 4 labs in the entire world that are doing this. Switzerland, France, Maryland, and Michigan. And they're not really focused on communications. They're just looking at laser filamentation in other kinds of applications. Some of them are farcical, in our opinion, like a laser lightning rod that France has been focusing on. And my comment is they're going to shoot a $10 million laser up into the atmosphere to draw a lightning pulse away from sensitive areas that Ben Franklin figured out 100-something years ago about how to do without spending $10 million doing it. So there's not any really that are on the communication side. There's some significant challenges still remaining. We've talked to Khaki Photonics. We've talked to a couple of OEMs about it, and where there's interest, it still has to get out of the lab, and we would actually be one of the first ones to be able to do a real live test. Saad, is there anything you want to comment about it? Saad is our photonics engineer. Saad, is there anything you want to add to that about where the state of technology is around the world?
So you pretty much nailed it on the head with everything else. And most of the technology regarding filamentation is focused on remote sensing of atmospherics. So you retrofit these to your satellites to detect nuclear materials in the atmosphere, or do extraterrestrial observations, so spectroscopic measurements. but nobody's actually focusing on ground to satellite communications or any of the other optical laser SATCOM technologies.
So what is the current TRL? It's in the lab, but what's the current TRL?
4. And we were hoping to get to 6, 7, which is a test in an operationally relevant environment, right?
Gotcha. I figure we can probably have a sidebar conversation. So if whoever wants to pass me your information, your email, I can follow up there.
Okay, I'm going to drop it in the chat. But if you look up laser filtration, you see just a handful of labs in the world. No OEMs are including it. They're using adaptive optics. We believe that the laser filtration coupled with adaptive optics would be much more powerful. And and people are just no one really looking at it from the communication side. Thanks, Devin.
Great.
Any other
Thanks.
questions?
Well, I think actually that's all the time we have for now, John. But
Yeah.
thank you.
I'll say something from a naivete perspective. When we put in the AFWERX proposal, we were very excited about being able to do a outdoor range test on an Air Force installation, and we didn't realize or anticipate just how many hurdles we were going to assume to try and get environmental, safety, power, civil engineering. The clearance for that it was. So that's why we really need to revert to an existing range and where most of those things are taken care of for us. Thanks, everybody.
Yeah, that makes sense. Yeah, unfortunately, not everything goes smoothly, and yeah, there's a ton of different regulations and approvals out there. So some of them for the good, some of them for the bad, and maybe things can be streamlined. Who knows? Well, with that, we'll move on to our final presentation of the day, which is InnoSys. And I believe Larry is going to present. So whenever you're ready, if you just share your screen.
See my screen okay?
Just a moment. Yes, I see it.
Okay, let's go to full, sorry, 1 second here. Go to full screen. Well, anyway, I guess let's get going on. Okay, so thank you very much for today. I'll be presenting on our technology. It's products that are very high extreme environment for various types of harsh environments, EMP, radiation, temperature, and also they run at very high temperatures again, and you don't need to be cooled. I'll go to my next slide. See, sorry, I have to put things out of the way here. Okay, and so basically, we'll present a very general discussion here. The details we can present to interested parties. We were founded in 2000 as a woman-owned small business. We have extensive microelectronics and additive manufacturing capabilities, including in ceramics. We develop electronics capable of surviving, operating in extreme environments and temperatures. Again, and also with electromagnetic pulses. These are high frequency RF systems and sensors and power electronics capable of operating for ground-based applications to deep space missions. Below are photographs of part of our clean room, one of our furnaces, part of our machine shop, and our 3D printer. And then, sorry. And so then we have, basically, we're talking about electrons that are essential for applications and exposure to high levels of radiation. Sorry, I'm just trying to minimize the 1 second here, sorry. Okay. High levels of radiation exposure that are unavoidable for Air Force and Space Force missions, including space-based missions, high-altitude platform, hypersonics, and nuclear environments. Electronics fail in high radiation environments instantaneously or cumulatively during long-term degradation, leading to permanent failure. To kind of take a quote from Will Rogers, our electronics have never met a radiation environment that they couldn't survive. They have never failed. The rad hard electronics play a crucial role in advancing space exploration, military technology, and dominance. Demand for rad hard electronics is increasing. The ability to survive attacks, especially in space, are very critical going forward. To avoid being neutralized and intentionally disabling destructive nuclear events. The problem, the need in the market. Again, rad hard components are critical to ensuring reliability in extreme environments, especially in space and satellites. Again, deep space probes, human-rated spacecraft communication, navigation systems, and of course, military defense systems and nuclear power plants and equipment handling radiation. Also, if there are dirty bombs, being able to go in there and interrogate the environment is very critical, and everything else. There's increasing emphasis on national security and defense applications, such as military satellites, nuclear power plants, and avionics. And of course, rad hard electronics play a critical role in this environment. Our electronics can operate at much higher temperatures and other conditions that other devices cannot. The radiation hardened market is expected to keep on growing and reach over $2.5 billion by 2032, with a AGR of 4.45 over that period. The high temperature electronics is a larger market and expected to reach 18.5 billion by 2029, growing at 9.4 annually. So kind of our core tech, our solution, is we have developed over the last couple of decades technology we refer to as solid state vacuum devices, SSVDs, diodes and transistors, and other types of electronics that present a revolutionary solution. They combine the advantages of both solid state semiconductors and vacuum electronic devices into new high performance device technology for extreme and harsh environments. Once fully commercialized, these devices should find a wide adoption for demanding applications. In the photos you can see below, there's a small scale integrated circuit there, which has a number of these devices. Here's a photograph of an op amp that's made on ceramic. And then here's some IV curves taken by NASA before and after 500 degrees C testing. And then here is our Venus transmitter data taken both at NASA and our own internal testing. Up to 550 degrees C, we can transmit anywhere from basically near DC to over 3 gigahertz, and with no degradation in performance at high frequency and high temperature. Then some Air Force use cases. We've also done W-band high power amplifiers based on this type of technology for V and W-band military satellite communications under AFMC program. As I just mentioned, we've done S-band transmitters, which passed NASA testing for potential use in Venus missions. We are currently modernizing some power supplies for the Air Force. We also do, high voltage power supplies and also low voltage power supplies and high power supplies. We're also developing extremely high efficiency compact power supplies for various accelerators for national labs. Again, these are very high reliable, long life operation devices that can be used for space fence at S-band or higher frequencies. They're also can be used for other type of things where the EIRP and sensitivity required to be able to see and characterize particles in space is very critical for both space assets and astronauts and other space fence and Golden Dome applications. We can provide the high power extreme electronics for these devices. We also have sensors. We have temperature, pressure, other types of imaging sensors too. They can be used in other defense applications, including the newly announced Golden Dome and Shield sensor radars, etc., of MDA. And they also can be used for extreme temperature hypersonic applications. The advantages over status quo and other solutions. We have third-party verifications. This can be discussed at further time with interested parties, as there are some restrictions on what we can say about this openly. Our business model and go-to-market plan is to build commercial off-the-shelf components and also custom-made ones for military and defense needs. Partnership approach, we work with customers, equipment system houses, integrators, each application area. We partner with prime defense contractors for military and civilian transitions. We maintain direct contacts with the AFRL and potential other military end users. Our business model is direct sales through product manufacturing, non-exclusive licensing for very large quantities or operations unsuitable for a small business like InnoSys. Our goal is to encourage broad industry adoption to make rad-hard extreme temperature electronics more accessible and more rugged. Our market strategy is kind of twofold, dual use. Military, we want to leverage defense contractor partnerships to identify system platforms requiring rad-hard extreme temperature electronics. Commercial is to use internal marketing, sales team, and sales representatives for dual use applications. The overall objective is to capture a significant market share in extreme and harsh environment electronic markets. The traction we have so far is we work a lot with AFRL, AFMC, the Army too, Air Force in general, nuclear facilities, NASA, DOE labs, and defense contractors. Our team, we have about 30 engineers, 30 employees. In addition, we have our CEO and chair, Dr. Jennifer Hu, who earned her PhD from UCLA and was also was the founding member. And she was a University of Utah professor until she left, as I did, to join and form InnoSys. My background is also electrical engineering with a PhD from UCLA in solid state physics. And also I was a University of Utah professor in MEMS and computer engineering on high temperature electronics. Steve Cox is our Chief Marketing Officer and has over 25 years experience working with large corporations. The ask is for Air Force partners for TAC-FI, STRAT-FI, DoD partners for other DoD post-phase 2 programs, for example, MDA Shield, potentially investment or money in exchange for royalties, pre-sales, or combination thereof. I should mention we are in the process of being awarded, which should happen maybe this week or early next week, a direct to phase 2 AFWERX manufacturing SBR to further develop the high volume manufacturing of this technology. And that's basically it. Please feel free to contact any of us, myself, Dr. Jennifer Hu, Steve Cox, and there's our contact information and our phone numbers. That's basically my presentation. Any questions?
Thank you so much, Larry. So yeah, opening the floor to questions. This is the last presentation of the day, so the last opportunity to ask questions if someone wants to ask. Just a reminder, I saw Todd already just did this, but it's a reminder for those who may have forgotten, despite my mentioning this basically after every pitch, but to raise your hand virtually, which is how we call on you to ask questions, just click on the react button on your control panel to raise your hand. So it's either right there or under more on your control panel. So we'll have the first question from Todd. And Todd, if you would just introduce yourself briefly before asking the question, that'd be appreciated.
Yeah, sure. Todd Coulard, principal at Mark Ventures. Larry, great presentation. Just a question about your current production volume and throughput. Can you talk about that?
Yeah, it's pretty low volume right now. We can produce very quickly. It's mainly limited in our packaging at this point. And that's what the AFWERX phase 2, direct to phase 2 will address, is being able to manufacture in fairly high volumes at fairly rapid rates and everything else. So we can produce right now dozens per week. We should be able to go to thousands per week at the end of our direct to phase 2, which is this, again, has not officially started yet, but will start before the end of September.
Got it. Thanks.
Thank you.
We have time for another question if anybody has any. Once again, last opportunity to ask questions for the day. So especially if somebody hasn't asked a question yet, highly encourage. We'd love to hear some more folks, although also happy to have people who already ask questions. Ask questions if you have one. I guess I could just ask something real quick, Larry. Is there a specific phase 2 that you're basing or that you would like to base the TACFI on? And would you maybe be able to extrapolate a bit what you did in that project and how you'd like to build upon that under a TACFI project?
It's a very good question. We have current DOE phase 2s mainly on power supplies and some rad hard components for a very extreme environment. These are non-electronic components for extreme environments. And we also have Army phase 2 and very high frequency communications. And we have other non-SBR topics. I don't know, we like to try and base it on our current or about to be phase 2, direct to phase 2 AFWERX manufacturing, because that's what I think we really like to put emphasis on, is be able to manufacture these devices and get these out. We're looking at both RF up to X-band and possibly beyond, and power supplies that are designed to survive extreme environments, temperature and other, considerations. So I think that's what we're looking at right now. I think you can go back several years. So we do have other projects that we could look at too, Air Force and NASA and DOE projects too, depending on the interest from the hopefully potential government customer.
Sorry, this is Jennifer. Is okay I try to help to answer this question?
Definitely.
So I think with what Larry just described, we are very interested in doing a TACFI for supporting MDA Shield program, which we think we will be very suitable for sensor, for radar, hardwares, and with our manufacturing capability, we definitely think we will be able to support the layer of this dome all the way from ground up to deep space. So that's what we are very interested in.
All right, great. Thanks for clarifying that. So just the final minutes of the event. If somebody happens to have another question, happy to entertain that. I'm not going to prevent from doing that. So we'll just give that a second for someone to raise their hand if they want to raise their hand. But if not, Larry, if you would just put your contact information, so Steve already put the contact information in the chat. Steve from InnoSys. So thank you for that. So if anybody wants to reach out to anyone from their team to learn more about their technology, what they're working on, because from my understanding, they do have a lot that they're working on and have worked on over the years with the government. Definitely feel free to reach out, ask questions. But thank you so much again, Larry, for that presentation. Especially under relatively short notice, that's quite good.
Thank you.
Sure, thanks. So that's it for today's presentation. So I'd like to thank everybody who joined. Huge thank you to the companies who put together these great presentations and did a lot of work to get to this point to have one or multiple phase 2s to be able to be eligible for this event. And all the groundbreaking work that you're doing. Really appreciate that. Huge appreciation to all the panelists who took time to sit in and watch these presentations, ask questions, participate, help make this event a great event. And just in terms of housekeeping, I will send a recording of this event and follow up probably either later this week or early next week. So just keep an eye out for that. And again, if anybody has any questions or any of the panelists want to connect with any of the companies, you could either reach out to the company directly, or you could also just reach out to me, say, hey, such and such company was interesting. Can I get a connection? And I'll be happy to make that connection. So thanks again to everybody who joined, everybody who participated and took the time for this event. Hope to have you in some of our future events, and have a great rest of your day. Take care. Bye.